Hello class, it is your teacher Mr. Tachi. I am here to teach you guys about Newton's second law. So we've learned about Newton's first law, but now we're moving on to Newton's second law. Now the second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of that object. So it basically is just this equation, F net equals ma, or acceleration equals F net divided by mass. Now F net stands for the net force affecting the object's acceleration. So it's only the forces that are affecting the object's acceleration, nothing else. So I have an example of that. So here in this example, we have a 10 kilogram mass. There's an applied force of 12 newtons pointing to the right, and it's told to be there's no friction. So there's no friction, therefore the thing is it's gonna accelerate. So the first thing you gotta do is you gotta draw the free body diagram. So we have force of gravity. Oops, hold on one second. Let me change the thickness of the pen. Force of gravity acting straight down. All right, we have normal force acting straight up. Sorry for the bad drawing, but normal force pointing straight up. And then we have the force applied pointing to the right. Now, the force applied is the force that is making the objects accelerate. So the force of gravity and normal force are actually not really important in this particular example, right? Because those two forces are perpendicular to the object's acceleration. The object will accelerate to the right because that's where the unbalanced force is. It's going to accelerate to the right. So that's where the unbalanced force is. So to figure out what the acceleration is, we can do A is equal to 12, the net force, divided by 10. And that will give us 1.2 meters per second squared. All right, that's pretty bad, but you get the point. Meters per second squared. Okay, 1.2 meters per second squared. And that would be the acceleration of that particular object. That's it. So you only look at the force that is affecting the acceleration. And in this case, it's just Fa. Now, in some cases, you will have a frictional force, right? And that frictional force might be given to you as something smaller than Fa. So you have to take the difference of those two forces. And we'll be doing more examples later on. Thanks for listening. Hopefully that makes sense to you guys. But we'll see you soon.